Okay, so grade 9, this is section 2.1 on rational numbers. These are the questions from the textbook that we were assigned. Question 1 says, Laura placed 2 and 1/2 incorrectly on a number line as shown. How could you use the ideas of opposites to show Laura how to plot 2 and 1/2 correctly? So what we really wanted to do is take this number line, oh, I'll do black, take this number line and extend it for 1, 2, 3, and 4. And I think most of us would know that 2 1/2, if it was positive, would be right here, 2 1/2, okay? So the distance from 0 is 1, 2 1/2. Now, if you're going to place negative 2 1/2, you would have to do the same distance. It has to be equidistant, so 1, 2 1/2. So the correct position for 2 1/2 is not between 1 and negative 2. It's between negative 2 and negative 3. So the idea is opposites in negative integer land are always equidistant or the same distance from 0 and its positive counterpoint. Question 2 was skipped. Question 3 says Thomas and Roxanne were comparing negative 9/10 and negative 7/8. Thomas wrote negative 9/10 as a fraction. And then he compared the two fractions. So he tried to compare these two to see which one was bigger. Roxanne kept Thomas's 9/10 and she changed negative 7/8 to a decimal. So if we wanted to change that to a decimal, we'd take our calculator, our handy dandy notebook calculator, and we would change that to a decimal. And we know the easiest way to change a fraction to a decimal is to divide the numerator by its denominator. And we would change that to negative 0.875. Okay, so this is Roxanne's way. And the other one was to change 9/10 to this one. Sorry, this is up here. All right. So this is Thomas's way right here. Thomas. So whose was easier, this one or this one? The answer is Roxanne is easier to compare, and the reason why is because even though Thomas converted them both into fractions, you can't tell what size they are unless they have. So the answer is they need to have common denominators. So I would still have to go one step further by finding common denominators, and then I would have to change this to negative 36/40 and negative 35/40. And to be honest, that's a pretty good way to say which one's larger if they have common denominators, but it just requires one more step. Since this one is smaller to or closer to 0, this one would be the larger of the two, and this one would be the smaller of the two since we're dealing with negatives. Question 4 says match each rational number to the point on the number line. So the first thing we probably need to do is, and the easiest way we need to do is just look at the first one and say what number is that. So 3/2 is the same thing as a mixed fraction, 1 1/2. Since 1 is here, and it's positive by the way, 1 1/2 would be D. For the next one, this is D. For B, negative 7/10, well we know this is 0 and 1. So negative 7/10 is somewhere between nothing and negative 1. And since there's only one letter in between there, we know the answer for that has to be C. For question C, negative 2 1/5. So just like the first question, negative 2 1/5. A lot of people might have said B because they're reading it negative 2 here and then more would be on this side, but that's not how you read it. So negative 2 1/5. If I did positive 2 1/5, that would be right here, or 1, 2 1/5 away. So the equidistance would be 1, 2 and a bit. So the answer for negative 2 1/5 is A. And remember, a negative fraction would be equidistant to its positive counterpoint, equidistant to 0. When we do D here, we want to look for negative or positive 14/5, which would be 3. No, it wouldn't. It would be 2 as a whole number, and 4/5 as a mixed fraction. So I convert it first to that. And then we have 1, 2, The 4/5 would place it around there, which means D is E. And since I don't really want to do any more work because I'm lazy, the only other letter that hasn't been done is B, negative 1 1/3. So 1 1/3 makes sense. Question 6, place each number and its opposite on a number line. So I'll make a number line here, and I'll put 0 right in the middle. Now the first thing I have to do is determine what is the range of my numbers. This one here is -3. This one here is -3 2/3. So the farthest I'm going to go is -4. So -3. This is the worst spacing ever. -3. No, that's all right. That was fine, actually. -3, -2, -1. There we go. -2, -1. Then we'll do equidistant 1, 2, 3, and 4. So our number line is created. I'll grab a different color. Actually, I'll draw. Oh, let's use pretty things. Let's use happy faces. So I'm going to place 8/9 on the number line. Now, 8/9 is going to fall somewhere between here, right? 8/9. So if I use my pretty, I got to get it out again, my pretty happy face, 8/9 will be there. So 8/9 is between 0 and 1. -1.2, I'm going to have to use this marker, but that's okay. That is -1.2. So that's going to fall right there for -1.2. 2 1/10 would be 1, 2, and 1/10. So that's going to be right there-ish. And -11/3 is the hardest one we have. So if I convert this to a mixed fraction, it's going to be -3 2/3. -3 2/3. So if I place that happy face on that, -1, -2, -3, and 1/3, 2/3, right there would be where -11/3 goes. Question 8 says compare these fractions and write the numbers in ascending order. So the first thing we're going to do is convert them all to the same format. So we have 3 of them are fractions, 2 of them are decimals. Brock will tell you that it's always easiest to change rational numbers to decimal form to compare them. So that's what we're going to do. So 1 5/6, in order to figure out what that is as a decimal, I'm going to just take my calculator and divide 5 by 6. Not 1 5/6, just 5 by 6. So the 5/6 part is 1.83 repeating. That's what 1 5/6 is. It's positive. -1 2/3, I think we all know what that is. So 1 2/3. 2/3 is 0.6 repeating, so this is going to be -1.6 repeating. Then those two are already as is. And then the last one, -1/5. You probably know that this is equal to -2/10, which is this is a decimal. So therefore, since these are equivalent, this is also -2/10. All right. So now we have to compare them and order them in ascending order. So I'm actually going to use a number line for this. And I'm going to put 0 here. And my range of numbers, again, the lowest small negative number is 1.6. So make this -2, -1, 0, 1, 2, maybe I need 3, who knows. Okay. So the smallest number I have, it has to be either this one, or this one. And I have to compare them. So -1.6 repeating, -0.1, and so this is my smallest right here. So that's going to be my smallest. I'm going to put -1 2/3 as my smallest. I'm going to cross it out. Then looking at between the other ones, this one is -0.1. This is -0.2. Remember, the farther it is from 0, the smaller it is. So this one would be here, and this one would be here. So -0.2. I got a lot of stuff going on here. Is my next smallest, which is a fraction. And I don't have a very good eraser. -1/5. My next smallest would be 0.1 negative. My last two positives, 1.9 versus 1.83. 1.83 is the next smallest, so I would put 1 5/6. And then my largest number would be 1.9. So please excuse all the rest of the clutter, but those are the order of your integers from smallest to largest or in ascending order. Now, so express each fraction as an equivalent fraction. So to be honest, there are infinite answers to all of these questions. So if I took negative 2/5 and I multiplied both by 2, an equivalent fraction would be this. If I had taken my negative 2/5 and multiplied it by 111, I would get 222 over 555 negative. An equivalent fraction still has the same value. So whether I take my calculator and I take my calculator and say, what is 4 divided by 10, and it says decimal 4, or I say, what is 222 divided by 555, it still tells me it's decimal 4. So equivalent fractions carry the same decimal value or same amount regardless of what their numerators and denominators are. They are equivalent. Okay. Question B, we have 10/6. We can multiply by any factor. I'm going to multiply by 2 just to keep it simple. So an equivalent fraction would be 20/12. For negative 9, again, I'm going to keep it simple. I'm going to multiply by 10 this time just for poops and giggles. I get negative 90 over 120, which is still equivalent. And this time I'm going to multiply by an absurd number, 3. I get negative 12 over 9. So your answers will be different depending on what you used for your multiplier of numerator and denominator, but regardless of what you use for an equivalent fraction, the decimal value will always be the same. Question 12, which value in each pair is greater? So the first one, I have a positive fraction and a negative fraction. And since we're looking for the greater fraction between those two, I can definitively say the positive value will be greater than any number that's negative. That's like saying, which is greater, 1 or negative 26,000. The greater between those two will always be the positive value. Yes, exactly. So the answer for A is 1/3. The answer for B is 7/10 because the other one is negative. Now we have to do some thinking here. What's greater, negative 1/2 or negative 3/5? The simplest way to do it is convert them both to decimals. And then if you need to, look on a number line to see which ones they are. So right in the middle would be negative 1/2. And negative 0.6, which is negative 3/5, would be there. The closer it is to 0, the larger it is. So therefore, negative 1/2 is larger than negative 3/5. And conversely, I think all of us know that a quarter is greater than an eighth. So if I was to place this on a number line, negative 2 1/8 would be here. Negative 2 1/4 would be here. This one is closer to 0. And therefore, oh, sorry, wrong circle. Therefore, 2 1/8 is greater than 2 1/4. Question 15 or 13 we're going to skip because it's the exact same as 14, just asking the opposite question. Question 14 gets a little complicated. It says identify a decimal number between each of the following pairs of rational numbers. So there are multiple ways to do it. The first thing I'm going to do is I'm going to show you how to do it with fractions. So 3/5 and 4/5, it seems like there are no fractions in between it because we want to say something like 3.5/5. But my math teacher told me you can't put a decimal in a fraction because that's a part of a part, and part of parts are very complicated to think about. So what we really want to think about is equivalent fractions where there are spaces between the numerator. In this case, if I took an equivalent fraction of 30/50ths and an equivalent fraction of 40/50ths, both sharing the same denominator, now I can see a plethora of fractions that would fit in between there. Anything from 31/50ths, ... all the way up to 39/50ths. Each of these can be then therefore created into a decimal number. So if I took my calculator again, which I think is here, it's right there, and I'll use this one, and I said, what is 31/50ths as a decimal? It would have the decimal 6.2. So that would be one acceptable decimal. between there. I could also ask what is 32 divided by 50 and change that fraction to 1. It would tell me 0.64. That is an acceptable answer as well. Okay? Now that's one way to do it. You can convert them into fractions, equivalent fractions that have spacing, and then find any fraction and then convert that to a decimal. In the second example, another way to do it is to change them both into decimals and compare them. So -1/2 would be -0.5. -5/8, if I use my calculator, would be -0.625. Okay, so I immediately convert both fractions into them, and then I could find any fraction between there. So, or decimal, excuse me. So one of the decimals that would fit between there would be -0.6, and that's another way to get a correct answer. But you could do -0.52, -0.59, -0.62 would be between there. All kinds of different fractions you could use. For question C, a little bit more complicated, but not really. Identify a decimal number between here. So if I was to draw this and put 0 here and 1 here, and -1 here, this decimal, this fraction, -5/6, appears here, and 1 appears here. So the easiest number to say fits between there is 0. 0 is a number that fits between those two, or 0.0 if you want to have a decimal in there, or 0.1, or -0.2. There's a whole bunch of numbers that fit in between there. That's another way you could do it. Draw a number line and look at it. And finally, -17/20 and -4/5. For this one, we can use either convert them to both to fractions. Let's do the fraction one again. So -17/20, and an equivalent fraction to that has that denominator is -16/20. And you're like, gosh darn, I can't. So again, given the fact that -17/20 and -16/20 are too close in proximity to allow for a fraction to go between them, what we can do is change them to equivalent fractions. In this case, I'm just going to multiply by 10. And I'm going to look at them again and see if I can identify a fraction in between there. Of course I can. I can see anywhere from -161 over 200 all the way up to -169 over 200. And any one of those can be converted into a decimal. So I'm just going to choose the first one. Let's see if I get my calculator here. -161 divided by 200. And that is going to be -8005, which would be a decimal that fits in between there. Okay, that would be one. And you could do the rest of them, -162 over 200, and so on and so forth.